So in this video, I'll show you how to um, trace the PDA related to ones that are equivalent to context-free grammar. So I'm just going to do one example where it is actually accepted because the tracing of this is similar to the tracing of a regular PDA. So let's just take a look on the behavior of the stack in this case, because we do push several times into the stack, and that's probably the only difference. So let's take a look at if I had this input and we had this PDA that is equivalent to this context-free grammar. So what would be the behavior of this? So we would first of all always have the Q start, and immediately the Q start would do these two things because it ignores everything, the stack and the input, and it just pushes onto the input these two one after the other. So what would happen is that we would go to Q loop, and we would have pushed two things onto the stack, the start variable and also the $sign. And then after that, we would have to make a decision where we would move. So we need to explore all our options. So right now we are at input A, and we can use this. Let's try. So we have input A. So this is the only option that I can use for input A, which is A and then A on the stack. There's no A on the stack, so that is, we can't use that. We can't use this because B is not the input. So let's explore the options where we ignore the input. So when we ignore the input, either on top of the stack it's a S or a T. So in this case we have S, so we can only use the loops that are related to S. So the first one does a series of pushing onto the stack, so it pushes B, T, and A, and the other one pushes B. So what we're going to do, we're going to explore both of these options. So they all go back to Q loop. Okay, so you can write this or not. I know where it's going, and you should also know. Okay, so now this side is going to push B by using this one, and this one is going to do a series of pushing onto the stack, which is, of course, it's going to do first B, then T, and then A. So each one of these sides now has its own stack based on the transitions that we took. So we're going to explore each one at a time. So as you can see, we still did not do anything with our first input. So now we're going to go back and explore if we can use it now. Okay, so we can use it now because we have A as input, we have A on top of the stack, and so we can use this one for this side. Now for this one, we have B on top of the stack, and here you can see that B needs to have also input B. So this one we can't use this one. We also can't use it for any of the other ones because S is not on top of the stack, T is not on top of the stack, S is not on top of the stack, T is not on top of the stack, and so we can't use any of them, so this one dies. Now this one lives, and so what happens is that this does nothing other than go back to the loop. It does not do anything to the stack, but it pops out A. So what's going to happen here is it's going to go back to loop, and it's just going to pop A, and T is going to be on the top. So right now we're going to move the pointer because we already used the first A in the input, so we're going to move the pointer to the next A. So right now we are here and we have T on the top of the stack. And so what we can do, we're going to explore our options. So the top of the stack does not have an A, so we can't use that. Does not have B, we can't use that. Does not have S, does not have S. So the top of the stack has T, and we can ignore the input and explore both options. So the first option would be to just reproduce the same thing by popping T and then pushing nothing onto the stack. So we would go back to loop, and then we would have $ and B, or we can push out T and then, pop T and then replace it with A and then T. So we're going to explore that option. So we're going to here push, we have B, and then we are going to replace T with A and then T. So we're going to first put A and then T. So now we are going to go to A again, and we can see that now we have for this side, we have on top of the stack B. So basically we need to have another B for this to live. Because the top of the stack is not A, it's not T, it's not S, so we can't use any of these. So this will die. And now this side has a T on the top, and so we can ignore the input for now and then reproduce this. So we're going to pop T and then do nothing to the stack by using this one, and we're also going to use this one. So we're going to have two ways to go, this one and this one. So let's do the first one by just popping T and do nothing else to the stack. So we have A now on the top, and we have on the other side, we are going to have replacement of T. Okay, so we are going to replace T again with a T. So, okay, so now let's take a look at this side. This side will, in the next phase, it will live. Because we have A here and the pointer in the input is now at A, so you can see A and A, so we can use this one. So what's going to happen is that it's going to loop. So we have here this and B, and we're going to go back to loop, and now the pointer is going to move to B. And here we have B, so now we can use this one and transition. In this case, that's the only option as well. And so we're going to transition to, again, to Q loop. And then after that, we would have only the $. So now the top of the stack is the $, so we can move on to Q accept and pop the $. And so now we have an empty stack. So this means pop the $, and move to accept. And so now the string finishes, and we are at accept. So AAB is accepted. And remember when we said that in non-deterministic, if any one of the branches accepts, then it is an accept. we can continue to explore this branch. So what's going to happen in this branch is that we can again substitute either by popping T and having a stack that looks like this.